Hi, my name is Julian Simpson, 0551F1044. Okay, first I will present about the introduction. Sago is a type of starch that commonly extracted from a palm called Petrokimia sago. It's mainly composed of starch and is low in protein, fat, fiber, vitamin, and minerals. However, sago is generally grain-free and gluten-free, making it suitable for those following strict diets. This is a natural resource which has a potential to be used as a raw material for biocomposites such as bioplastic. Bioplastic or biodegradable plastic is one of the alternative replacement to conventional plastic that has the potential to harmful of the environment.
Assalamualaikum and good morning. My name is Noeliana Izzati binti Omar from DPE 5B. Today I would like to present about objective, research, review, and result for solubility and degradation of acetic acid. First is objective. To produce the sample of biodegradable plastic from sago starch, to compare the sample of sago starch with for the biodegradable plastic, acetic acid, and citric acid, to evaluate the plastic properties, heat resistance, water solubility, strength, and combustibility.
Problem statement. The increase of commodity synthetic polymer and it is damaging the environment. High cost in plastic manufacturing. Scope. Number 1. Get sago flour from supermarket. Number 2. Using 5 ml, 10 ml and 15 ml of acetic acid and citric acid. Number 3. Produce biodegradable plastic in A4 size. Number 4. Test the properties of the plastic. Number 5. Using drying process to produce biodegradable plastic.
This is our literature review of our project, specifically to develop the biodegradable plastic from sago starch and study the properties such as biodegradability, mechanical properties, and resistance factor in order to produce good quality of biodegradable plastic products that are eco-friendly. Second, the presence of water in the soil will be absorbed by the sago starch-based biodegradable plastic due to the different concentration of water between salt and plastic. Third, the sago starch-based biodegradable plastic is degradable because clear texture that after 40 days, the major chemical inside the sago starch-based biodegradable plastic is disappeared. In conclusion, the sago starch-based biodegradable plastic is degradable because clear texture that after 40 days,
Production of sample sago starch biodegradable plastic during process. Mix 25 grams of powdered sago starch with water 150 ml in a beaker. Heat up with hot plate about 70 degrees Celsius. Add 10 ml glycerol and acetic acid in a solution. Stir the solution of sago until it becomes colorless and springy. Put the solution in the baking paper in A4 size. Dry it under the sun for 3 to 4 days. Repeat the process by using acetic acid and citric acid.
Citric acid solution preparation. Weight 74 grams of citric acid powder and place in a container. Add 51 ml of distilled water to the container. The solution is stirred until it clears to ensure a faster and more complete solution. Procedure of degradation test. Place the biodegradable plastic in the soil. Dig and record the changes after 14 days. Procedure of strength test. Strengthen the biodegradable plastic. Put the 100 gram weight iron on it and observe the changes of it. Repeat by using 500 gram and 1000 gram weight iron.
Procedure of heat test. Pour 500 ml water in a beaker and heated it until 30 degrees Celsius. Then put the biodegradable plastic in the water to be soaked. Take it out after 1 hour and repeat by using 60 degrees Celsius and 90 degrees Celsius of hot water. Procedure of solubility. Soak the biodegradable plastic in the water and observe and record the change for 7 days.
This is our result for heat test for sample of sago starch biodegradable plastic of citric acid.
Degradation of acetic acid. This is a result for degradation of acetic acid. From day 1, 5 ml, 10 ml, and 15 ml of acetic acid is shrinking and not easily to decompose. From day 15, 5 ml, 10 ml, and 15 ml is shrinking and very easily to decompose. Comparison between the three quantities of acid, 5 ml of acetic acid is more easily decomposed than 5 ml and 10 ml of acetic acid, even take a short time to decompose.
Hello, my name is Marilyn Awing and Jabatan. My matrix number is 05TPE1 and F1029. So I'm gonna to present about degradation test for citric acid samples. From day 1 to day 14, only 5 ml of citric acid samples shrinking not easily to decompose. For 10 ml and 15 ml of citric acid samples, they are expand and easily to decompose.
Okay, next one is result. Heat test. Result sample of sago starch biodegradable plastic of acetic acid. Therefore, 30 degrees Celsius, there are no chance for the plastic at 60 degrees Celsius. For 5 ml acetic acid, is become easily turned soft and expand. For 10 milliliters acetic acid, not easily turned soft as expand. And then for the 50 milliliter biodegradable plastic, not easily turned soft expand. And for the 19 degrees Celsius, for the 5 milliliter easily turned very soft and expand. For 10 milliliter, not easily turned soft and expand. And then for the 50 milliliter, not easily turned soft and also expand. That's all from me. Thank you.
For heat test of citric acid samples from 30 until 90 degrees Celsius, the samples are soft and easily to turn.
Solubility of acetic acid. This is the result of the solubility of acetic acid. From day 1 until day 14, the 3 quantities of acetic acid is soft, easily turned, and easily textured. Comparison between the 3 quantities of acetic acid, 15 ml of acetic acid is more easily soluble than 5 ml and 10 ml of acetic acid.
For solubility test for citric acid samples from day 1 until day 7, only 5 ml samples are no change, only wet, and the color from colorless turn into white. For 10 ml and 15 ml of samples citric acid, they are jelly texture and easily to turn.
Hi, my name is Alana Setiana Franklin and my registration number is 05DPE19F1013. Today I'm going to talk about strength test. Result sample of Sago Starch biodegradable plastic for acetic acid, which is for 5mm, 10mm, and 50mm. The weight iron that we use for strength test is 100 gram, 500 gram, and 1000 gram. Overall, for each sample that we recorded, there is no change in the biodegradable plastic.
This is our result for strength test of sample of Sago Starch biodegradable plastic of citric acid. This is our cost for our project. We are using Sago Starch powder, baking paper, glycerin, acetic acid, citric acid. The total for our project is 15 ringgit and 65 cents. Conclusion. In the term of national economy, it can reduce the cost of manufacturing plastic because the plastic is made from raw materials such as sago. This is due to the fact that sago is widely available and inexpensive. Among the advantage of our sago biodegradable plastic that can be distributed to the environment is that it can be reduce environment pollution because it does not need to be burned. It can be planted in the ground or separate for recycling. This is because this plastic requires a short time to decompose and do not require a long time to be removed like synthetic plastic. In addition, biodegradable plastic contain fewer chemicals. Finally, we are able to promote Sarawak local products to the local market and develop the economy of the agriculture industry in Sarawak. And that's all from us. Thank you.